Okay. So we now know everything there is to know about loops, right? Do you guys have any questions on loops? Yes?
Whenever we have a return inside the loop, it's going to be like an if.
No. Return ends the function, right?
Yeah.
So if you have, let's do something here. Static int foo or loops return, right? If I have something like this, right? This is gonna be executing, right? If here somehow, right, I do this, and it's not just doing this, it's right that I'm doing it without any if, without anything else, right? What is going to happen when this executes, right? Or return x, right? What is going to happen? Imagine that I call this x with -3, right? It's going to print x, so it's going to print -3, right? Oops, and I'm sorry. Increment x, so now it's -2, right? And then return. That's it. The function is done. The loop is done. Everything is done. And you just return to the caller. So it only printed it once, right? So in this particular case, right, this is exactly the same as if you had done an if, right?
So just print -3.
It would just print -3. Now, it depends on the whole thing, right? You may have here, if I you have a return inside a loop, but in this case, it's not the same as an if, right? Because you're doing, so it depends on what you are doing in the return, right? In some cases, if it's something straightforward like that, then you're, right, the return, if you hit the return, you get out of the loop, you get out of the function, you're done. So depending on how you set up your loop, it may be equivalent to an if. And some of you were doing one of the assignment functions, right? Still using recursion, and that may be, you may be one of those. And so in that particular case, the way you had the while is just an if, not really a while. So that was the comment. But any other question on loops or the assignment or the meaning of life? No. Cool. Sorry?
Will you be discussing the assignment now?
I don't usually discuss the assignment. We take questions, right? Normally the assignment is, right? If the question is, what does the assignment mean, right? Or something generic, we make them on the class, right? If the question is, I'm stuck with the assignment, look at my particular piece of code, then we do that after class or by pull request, which is the ideal way of doing these things, but we can do it after class. That's perfectly okay. I don't know, what was your question?
I got my program correct, results were coming, but the detailed test, there was like one error.
Oh, yes, that's a general thing, right? I sent an email saying what was the problem.
Oh.
You didn't get the email maybe because you're not on my spam list. Maybe. I don't know. Did you get the email?
Okay.
If not, then that's something we need to fix, right? Sorry? That's perfectly okay. Sorry, I had a life this weekend. It's I tried I think Friday, and then my daughter had a dance competition. I didn't really have a life, but I didn't spend it doing this
I
stuff.
want to make sure that you're like I'm not the only one who's
If it is not touched, that's okay. That's I haven't gotten to it. If it is closed, then that means it's wrong.
no, it's not closed.
Yes, that's yes. I have like 10 merge requests that I haven't looked at all. Okay. This week, we are going to talk about something that we have actually been doing, but we never really talked about. Using objects, right? We have used, which kinds of objects have we used? Strings, right? What else? Scanners and print streams, right? But we haven't done much with them, right? We haven't systematically gone through what's an object and those kinds of things, right?
Yeah.
So we are going to go through them not next week, or actually a couple weeks. We will define our own classes and objects and things like that. Not this one. We have actually used another kind of object. We have actually used arrays. Arrays actually end up being objects. Weird objects, but objects, right? So for the most part this week, we'll use these three classes: point, rectangle, and dimension. For no particular reason other than the fact that they are fairly simple. So, what can we do with objects, right? We can declare variables. Let me do I think this worked. Yeah. Point P, right? I can declare a variable of type point. That's my object type. This doesn't do much, just creates a variable, right? If I want to create an instance of that object, what do I do? What did we do with something like scanner, right? New, right? With strings, we have a specific syntax for doing it, so we can do new point. Point is a kind of object, right? It's a class that Java defines for us, right? The standard Java library defines for us. And it's a 2D point of ints. So it has two variables, x and y, and it has a few methods, right? Has a new. You always have a new. Bless you. We can reference the fields with the variable name or whatever thing that gets us an object, right? A dot, and then the field name, right? The instance variable name. We can, depending on what the method lets us do, change that thing on the object, right? Depending on what the object lets us do. So in this case, a point is going to be something almost like an int, right? Except that it's going to have two ints, an x and a y. Does that idea make sense? Representing a 2D point in a graph or something like that, right? And the cool thing about it is that somebody else defined this for us, and now we have these methods, right? We have x, we have y, and so we can print p, and it will tell us something in our particular case. This is what this is printing. Is it always nice? I think it is. Yes. Every object has a toString method. And that toString method provides a representation of the object. That representation may be ugly. By default, Java prints just something. Or it may be nice. In this case, the object is nice enough and prints itself in a reasonable way. Does this idea make sense?
So what does it do, that method?
ToString returns a string representation of the object. You're asking the object, describe yourself as a string, right? Describe yourself with words. And in this particular case, and that's what Java will call, sorry, this makes it invisible. That's what Java will call if you print line the object or something like that, right? Java will call toString, convert it to a string, and then print it. And it will also do it if you concatenate to a string. Java automatically calls the toString method. Does that idea make sense? So this is more or less what an object does. You have fields, you have methods, and you can call them. You always reference a field or a method with an expression that returns the object, and for the most part, that's going to be a variable, right? Variable name or something like that. And then a dot and the field name or the method name. And if it's a method, you have to put parentheses, just like calling a function, and passing parameters potentially to the method. Does that make sense? Yes? No? Maybe?
When we are defining a point, it defaults, it takes x0 and y0, right?
By default, yes.
But can we define while creating a new point?
We can. This is where you go look at the documentation, right? What do they do? A constructor is what you use to initialize, right? And the documentation will tell you you can call new point with no arguments, right? You can call new point and pass it an x and a y, or you can call it with another point, and you would expect what? So we could do p equals new point 1, 2. By the way, what happened with the old point? We had a point, right? P was a point, right? What happened to the old one?
Is it also immutable?
A point is not immutable. We just changed it, right? Which is why we use point rather than integer or string, because point is not immutable, right?
We discarded it?
Sorry?
Did we discard the old one?
Well, the old one,
It's in memory, but it is orphan kind of.
it is orphan, right? When nobody points to it anymore, when no variable references it anymore, right? What happens to it? We don't really care because we cannot talk about it anymore. Does that idea make sense? Yes? We have no way of talking about that old point, right? So we don't terribly care, right? What is going to happen is that eventually, whenever Java feels like it, it's going to be garbage collected. Basically, it's going to come and say, oh, nobody's using this piece of memory that we allocated, so let's return it back to the OS and use it again if we need to. Does that idea make sense?
So, X and Y is like values or address?
X and Y are values inside the point, but this variable, P, only points to the point. So, yeah. The point exists in memory independently of the variable. You could have 10 variables that refer to the same point. Basically, we could have point P2 equals P, right? Now I have two variables of type point, P and P2. They're both pointing to the same object, right? So if I print P, I get x1. If I print P2, I get this. But if I do P dot x equals 100, P dot x is 100. What is P2 dot x? 100. P and P2 are talking about the exact same thing. Does that make sense? However, if I do P2 equals new point of P, P is 102, P2 is 102. But they are talking about I have two different points that happen to have the same values. Does that make sense? Now if I do P dot x equals 1, P dot x is 1, and P2 dot x is going to be what? 100. Because now you're talking about two different objects in memory. Does that idea make sense? You need to keep track of whether you have, let me try. Actually, I have something like this, pages. Yeah, I think I'd rather do it with. Don't do this. God. Especially not with your kids' account. No. Don't take me there. How can I? Here's your thing. I'm gonna use Google just because you don't let me do this thing. There should be a way where I can type stuff. I have P as a variable. This is why you use. Okay, ignore capitalization. This is why you use a text editor rather than, right? And then I have, let's see if I can insert table. Oh, I can insert tables and stuff. X1, Y2. Insert the drawing. Just a line. Oh God. Sorry. I'm not allowed to do nice things on this. I don't have a board. Basically, delete this thing. This P, I could have it so that P points to this guy and P2 points to, right? In this case, P and P2 have two different objects, right? Because I said P2 equals new point of P, right? The new operator creates a new point in memory, right? And actually returns a point, right? It's just a call like anything else. It's an expression like many other expressions and returns a point. And I'm storing that point in the variable P2. Does that make sense? So in this particular case, I have P and P2 pointing to two different objects, right? If I do, and I think I had something like this, right? if I do P2 equals P, right? Now what I did is change this guy to also point to this same object, right? To also refer to this same object. I'm calling it point because in C++ and stuff like that, you actually have pointers, right? In Java, we have references, and so they refer to the same object. And now this guy is orphan, right? At least neither P nor P2 are talking about it. In this particular case, nobody else is talking about it, so now we don't care what happens to it, right? To give us the impression of infinite memory, Java will eventually garbage collect it and remove it from memory, right? Return the memory and say, oh, this is now empty memory, as opposed to memory that's used by you. Does that idea make sense? Java does magical garbage collection, not every language does. In particular, C++, for those lucky you who are taking data structures, does not. So you have to do that magic on your own. Does that idea make sense? So, we talked about creating objects, and we create them with the operator with the keyword new, right? You put new, then the name of the class, and then any arguments to the constructor. A constructor is a special method of the object that builds the object, right? You can only build an object with the available constructors. So the class is able to not let you build things it doesn't want you to build, right? So here we cannot build an object and only pass it an X because the point class has this tree constructor. I can pass it either nothing or an X and a Y or another point, and that's it, right? And the new keyword creates a new object in memory. Keep in mind that objects have identities separate from their value, right? So primitives don't have an identity separate from the value. The number 3 is the number 3, no matter what, right? Objects do have an identity that is separate from their value. So here we could have two variables, P1 and P2, that point to two different points, even if they had the same value or not, right? And then we get into all this confusion of whether we are changing the same point or a different one, right? You pass arguments to your constructor. You can call instance variables. Objects encapsulate the state of an object, right, through their instance variables. They also encapsulate behavior through their methods, whatever I'm allowed to call, right? In a way, they are defining a language, right? The objects are kind of nouns, right? And the methods end up being verbs, right? And the states are other nouns that are inside, right? A point object has two pieces of state, x and y. We can access its pieces like this. In the case of objects that let us do that, we can access, set those fields, right, as if they were a variable. We also have methods. The object, the point methods has getX and setX. Maybe. Yeah, which, oh, Oh, it doesn't have set x in this particular case. They do have get x. It is fairly common for your classes to have get whatever and set whatever methods with the same whatever. So basically get x and set x in this particular case, which is very common, doesn't mean they all do, right? You can also come and look at all the methods that they have. We will see later that you have inheritance. Basically, you can define a class as a subclass of another class, and it gets all the stuff that you had defined on the superclass. So when you're navigating documentation, it tells you that it inherits from this class point 2D, and so it inherits all this stuff. So you can also call these methods. And sometimes they have nice documentation. Not always, but. Given that we have identity, we can have aliasing. You can have several different ways of getting the same object, right? And that can lead to problems because now you need to understand what you're doing. Right? You need to keep track of whether you changed it. If you have two ways of referring to the same thing, then you may change it one way and then get confused about the other, right? Does that idea make sense? The confusion we're having between P and P1's X and Y, right? There are several ways of dealing with it. If you can, right? If you have immutable objects, that tends to be really nice because it can never change, right? If not, if you can avoid aliasing, that is a lot better, right? But sometimes you can't. And so you need to be careful about what you're doing. Okay, sorry. Is there a question? Yes.
How many names can we give to a variable? Just only one, like py?
Wait, a variable can only have one name, right? But there can be many, many variables with the same value, right? An unbounded number of variables with the same value, right? That value can be a primitive, right? How many variables can you define within value 3? What do you mean 1? However many you want, right? The compiler will get tired much after you get tired, right? You can do int a equals 3, int b equals 3. How many can you do? Right? An obscene number. There is eventually some limit, right? There is only so much RAM that the machine has and things like that. But it's like, I don't know,
So it's
a gajillion. Sorry?
with points.
Same with points, right? I can do p, I still have p, so I can do point pa equals p, point pb equals p. Define a gajillion variables, right? And point c equals p, right? Doesn't have to start with a p or anything like that, right? So there is basically no limit. So let's see. What are we doing here? I'll give you a minute to think, and then I'll think it myself because I have no clue what I'm doing anymore. Haha. So what's some x?
15 and 10.
Some x is 15 and some y is 10? Is that what you're saying? Or that's PT1 is 15 and 10? PT1 is going to be 15 and 10 at the end, and PT2?
Some x will be
Some x is PT1.x plus PT2.x. So it's 15 plus 5, right? It's going to be 20. Maybe. Let's see. What are we doing? Reload so we lose this stuff, right? So now we have PT1, PT2. No, we don't have PT2 because this is a piece of manure. Never mind, we'll create PT2. Right? PT1 is 1010, PT2 is 55, right? Then we create point alias equals PT1. And then alias.x plus equals pt2.x, right? Who did we change? Who's x? PT1s or PT2s? PT1s, right? Alias is x, and we had set alias to point to PT1, so we changed PT1's x. PT1 says x. So now PT1 is 1510, right? Now we do alias equals PT2. Did we change any of the points? No, right? But we are changing who alias points to. So now alias points to PT2, not to PT1. So when we do this, we increase PT2's y by 5. So now PT1 is 1510 still, and PT2 is now 510. Right? So now when we do some x and some y, we get 20 and 20. It's a different 20, but one is 15 plus 5 and the other one's 10 plus 10, right? And then if we do y, does this make sense? If it doesn't make sense, or if this was hard, what do you do? What do you guys do? Go do a million examples, right? Go define your variables, define your aliasing, do stuff until you get it and until it's natural, right? How many examples do you need? I don't know. I have no clue whatsoever. Who can know? You, right? At least you can know, do I need more, right? And if you do need more, then what do? Do a million more, right? Drop and give me 20. That's the only way, and only you know. Rather than, if you were undergrads, I would probably torture you with quizzes and stuff to force you to do 100 of these. You're grad students, I'm treating you like adults. You do as many as you need, right? And I'm trusting that you will actually do as many as you need. In Java, a class is a template kind of for objects. So every class defines among them a toString and an equals method, among other things. We actually have in Java a class called java.lang.object that is the superclass of everybody. And so I can actually do object O equals new object. And by default, everything in java.lang gets imported automatically. And the object2 string has this horrible thing. It just prints a horrible number representing its identity. If you're taking data structures and C++, or if you're taking architecture, that's actually a pointer. That's actually the address in memory of the object, right? But if you don't and you don't terribly care, it's just a bunch of numbers. Is it a bunch of numbers or a bunch of letters? Both. It's a bunch of hex digits. It's in hexadecimal, so it's a bunch of digits. There. Hex digits. Hexits. And we use a few letters for the extra hex digits after 9. Does this idea make sense? So every object has 2 strings, and every object has equals, and maybe other stuff. God. I hate you, Java. Maybe this will tell me, right? Object, haha. A few other things. But in particular, we use toString all the time, and we will use equals. Yeah, they all have hash code too. What is dot equals, right? And is dot equals the same as equal equals? They are not. Equal equal tests for identity. Equal equal says, are these two guys the same object, right? Are they the same thing? Whereas equality, dot equals, tests for logical equality. Like, are they the same value, right? For int, it doesn't matter. An int is an int is an int. The number 3 is the number 3, right? But for other kinds of things, like points, it is not. When we do equal equaler, we are testing, are they the same object in memory? Are they 2 aliases for the same object? Whereas when we are doing equals, it's just, do they have the same value? And the class defines what the heck does having the same value mean. Does that make sense? Cool.
But if in the second line you put P2 equals P1, both of them would be true, right?
Yes, because we just put the exact same expression, so yeah. Right? Or, yeah, equal equal is always commutative, right? Dot equals is whatever the heck the designers of the class designed. So they are free to define all sorts of horrible things that would not be commutative. It should be commutative. You expect it to be commutative, but sometimes life sucks. As another example, we have the rectangle class, which we can come and see here. And you can go look at the documentation, specifies a rectangle in your coordinate space, right? An area. So how can you represent a rectangle? There's many different ways that you could. The Java guys decided to use a point for the corner and then width and height, right? they decided to use the upper left point and then width and height. How do X and Y stuff works on the screen and that kind of stuff, right? We have two reasonable representations. We actually have four possibilities, right? X could go, well, we have a gajillion possibilities. If we assume that X is, the X-axis is horizontal and the Y-axis is vertical, right? X could go positive could increase to the right or to the left, and Y could increase up or down, right? In English, we read from left to right, right? So everybody agreed that X goes from left to right. So the bigger the X, the more to the right you move, right? However, we ended up with a problem with Y. In English, how do we read in terms of our Y coordinate? Top to bottom, right? So that is one reasonable way of saying Y. Well, the bigger you are on Y, the more to the bottom you are, right? What's the other reasonable way to do Y? Y goes up. Why? Why would we do that? Because that's how they do it in math, right? For whatever reason, the math people decided, right, way before we had screens, that Y goes up, right? And so when poor computer people got doing it, they got really confused, right? And so I will forever be confused because it changes depending on the system, right? A bunch of people say, oh, it should go up, and a bunch of people say it should go down, right? Depending on what you're doing. In this particular case, Y goes down for AWT. Does that idea make sense? So I can create maybe. Oh, mouse is really nice, it's just not hooked up to my computer. I can create a rectangle, java.awt.rectangle. Okay, now I don't have all my points and stuff. I can do rectangle say this rectangle goes from 0, 0, 10, 20. Hopefully, yeah. The width is 10 and the height is 20, right? And then I can come and ask other stuff about, I can ask the rectangle for other stuff, right? I could ask it contains. Do you contain this point? What would it tell us? Yes. So it goes from 0, 0 to 10, 20. So it does contain 1, 2. Does that make sense? We can ask it other kinds of stuff. We could ask get height. Get width, get x, get y. We could grow width. We could intersect it with other rectangles, but I'm trying to see if we can do. No, we cannot cast. We cannot ask for the other coordinates. No, which is why I make you do that stuff. Yeah. But I could have, say, another rectangle. New rectangle from 5.5 to 10.10 or 10.30. And then do r dot intersection with R2, and that would give me another rectangle, right? From 5.5 to 5.15. Why? Should have given, oh, width and height, never mind. Right, height of 15, yeah, that's cool. It's not the bounds, it's the height. We can define functions that use objects, right? So let me do stuff like this. Import java.awt.point. By the way, AWT was or is a GUI library for Java that came with Java when Java used to do applets. Now nobody does applets, and if we do, well, the next version was Swing for GUIs, and now we do JavaFX or Android or other stuff that's not standard Java. So let's play, right? Let me define static How do we know if a point is to the left of another point? This is my right, this is my left, right? So when am I to the left?
X is less than.
Yes, so P1's x is less than P2's x, right? Oh God, I'm gonna paste the whole thing. Give me coordinates. What should we get? True, PT1 is to the left of PT2? No, right?
First is false.
PT1 is 1010 is to the right, right? So false, true, false, because we have less than, right? It would depend on our definition, but right now it's false. Run this thing. So we got false, true, false. Yay! Make sense? How do we get the area of a rectangle? With times height, right? That's the area of a rectangle, right?
Divided by 2.
That's triangle.
Okay, sorry.
It's okay. By the way, remember all that stuff because most of my examples from now on are like this. Yeah. Now, one important thing, right? If I do this, right? Let me leave the points there. What's the value of b after I call change it? What are the two possibilities? 5 or 1, right? It is still 1 because everything is passed by value in Java, right? And then I'm going to lie. No, everything is passed by value, right? So I passed the value, I made a copy of that b, right? So when I run it, I still get 1, not 5. That change it didn't do a thing. It didn't actually change it, right? Now, what happens if I do and here I pass a point. Let's do pt1. By the way, how can I do that? Overloading, right? I can have functions or methods with the same name as long as the arguments are different, right? If it confuses you, you can change things. What happened to pt1? Did it change or not? Yes, it did, right? What I'm passing is not the object, but a reference to the object, right? One way to think about it is my variables actually don't have objects, they just have references to the object, and so I'm always passing references. The other way to think about it is there is a special magical call by reference, and what I'm passing is a reference, right? Either way, the end result is the same. I just changed that whole thing. So what do I expect to get from this? 2010, right? Does that make sense? Similar to aliasing, right? Now this makes your life harder. Let me see if I can do something. Am I allowed to do this? Yeah. And it doesn't do a thing. Never mind. Final is a way of saying I'm not changing it, right? But it's not terribly useful because what it's telling you is I'm not changing the value of p, right? So if I define it as final, let me change the x and the y. It doesn't let me do p equals new point. Doesn't let me change the variable, but it does let me change the stuff inside it. So in this case of functions, it's not useful at all. Because I'm inside a function, I can change it, but I don't do anything anyway.
Why do we need the final?
We don't. Forget about it. We never wrote it. Why do we need it in other cases? Why is it useful in other cases? Because I can do stuff like public static final string my name equals Orlando, right? Then I can go use my name in other places. And by declaring it final, I protect it from changing it. It is useful within a class or stuff like that. It is not useful within something like this. It's not useful within as a modifier to a method arguments. Or it's mildly useful, right? I'm saying that I cannot change that argument, not the stuff that's inside whatever that argument points to, refers to. Does this make sense? Yes? Go do 100 and go look at assignment 6 too. I will go and try to grade assignment 5. Any questions on this stuff?
In what case do we need this point?
For assignment 6? In real life, if you're doing stuff that draws things on the screen, right? We haven't done any GUI programming. We have only said print, right? But if you want to draw buttons and things like that, you want to say, I'm going to put this button here, right? Here is a point, right? Does that idea make sense? In fact, that's why they created this stuff for GUIs. The GUI library for Java, AWT uses points and stuff for you to say, put this on the screen, put a button at this coordinate, or make a button at this coordinate and this big, so that we can have and stuff like that. We are using it in this class because it's a convenient example of objects, right, that are mutable, and that makes sense. You can see them, right? You can see what they represent and stuff like that. You would also do it in any kind of geometrical stuff, right? If you're writing a CAD program, then you need rectangles, right? If you're writing a game, you probably need rectangles, right? Whether you use the ones from AWT or not, right? Every gaming engine or something like that defines its own point class and goes from there, right?
My friend actually did a solar system with C++.
Okay, yeah. If you do solar system, right? Many simulations you need points and rectangles and stuff like that. Right? You use rectangles to decide whether two things collide and things like that. So any kind of graphical stuff, you would be using this. Or something like this, right? For this class, assignment 6. Because, right, we are doing it, in this class I'm not teaching you GUIs, I'm teaching you how to play with objects, right? And the stuff like, is this the same, is this equal versus equals, and that stuff applies to any kind of object, right? But that would be why you would use it in real life. Any other questions? No? Cool. And let me give you back 15 minutes of your life or so.